Hello. Infinite lifetime projects could be a challenge to calculate your annual worth. However, in this question, I will be uh, taking you over the process for calculating the annual worth for infinite projects. So let's take this example. An owner of a manufacturing company based in Bemidji, Minnesota, is looking to add an additional manufacturing line to expand his market share. There are three options to consider establishing the new line. Information about these options summarized in the following table. We have three alternatives, A, B, and C. A will last for 6 years, B infinity, C is for 6 years. And we have this information: initial cost, maintenance and operational annual cost, maintenance and operational every 10 years, salvage value, and the lifetime. If the market interest rate is 5%, use the annual worth analysis to choose the best alternative. If you see a scenario like this, where several alternatives, and one of them is infinity, that has an infinity lifetime, what you do, start with the alternatives that has a finite lifetime. So we're going to start with alternative A and C, and then we will go to alternative B and see how we could do the calculation. So what you need to do is build your cash flow for both alternatives for 6 years, because both alternatives A and C has a 6 years lifetime, and start looking into what transaction happening on each year. So on year 0, we have only the initial cost for alternative A, and this is equal to 100,000, and this is a negative because this is a cost, the initial cost, you paid this. And maintenance and operational cost is 15,000 from year 1 all the way to year 6. However, on year 6 we will be collecting the salvage value of $20,000, so the net cash for year 6 would be $5,000. We do the same thing for alternative C. 80,000 is the initial cost, and every year we have to pay 20,000 as a maintenance and operational cost per year from year 1 all the way to year 6. On year 6 also, what we have to do, we have to collect the salvage value of $30,000. Next, what we need to do, we need to calculate the present worth for these transactions. So we do the NPV function. Using the NPV function, 5% interest rate, select the values from 1 to 6, add to that year 0, and that would give you 161,000 as the present worth. Same thing do for alternative C. Use the NPV function, 5%, select the values from 1 to 6, add year 0 to it to find what would be the equivalent of these transactions in the present format. Once we have the present value for these two alternatives, A and C, we need to find the annual worth using the PMT function, 5%, and we need to, this project or this alternative will last for 6 years, so we need the equivalency of this number over the 6 years, and we have the present value would be the number that we calculated from the NPV function, and that would give us a 31,761. Same things, same function we use for alternative C, PMT, 5%, 6 years, and D11. So perfect. Now what we did, we calculated the annual worth for alternative A and C, that these both alternatives will last for 6 years. Now for alternative B, we've learned that the capitalized cost is equal to A, the annual worth, divided by I. So in order to find A, and we said the capitalized cost is another term of the present worth, right? So in order to find A, what we do, we multiply the capitalized cost, or what we call the present worth, times I. So whenever we see any number in the present format, we have to multiply it by I to find what would be A. So in this example, alternative B, there's an initial cost of 130,000. We multiply that by 5%, to find what would be the equivalent for this. And then we add to that the annual maintenance cost of 15,000. Actually, let's correct that to make it 15,000. So this is going to be 15,000. I'm going to correct this in my table. So this is going to be 15,000. So this is going to be 15,000. See if we could correct this here. Okay, so this again, this is 15,000, and then for the maintenance and operation every 10 years, we have to find what would be the equivalent of the 50,000. Also use the PMT function, negative PMT function, 5%. We're trying to find the equivalency of this amount over the 10 years, and we don't have a present format. The 50 is a future format, and negative 50,000, and that would give you an annual worth for alternative B to be 25,475, and therefore which option we should select? We should select alternative B, because this will give us the less expensive option. So I'm going to correct that to be 15,000. Please correct that. 15,000. Okay, I hope this is helpful. Just one more time for the infinity, just to make sure that it's clear. For the initial cost, we multiply it by the interest rate of 5%. For the annual maintenance and operational costs, we add it as is. Make sure it's a negative. For the expenses that we will receive that we have to pay every 10 years, we have to use the PMT function of PMT 5% for 10 years, and we use this amount, the 50,000, as a future amount because that's going to happen in the future, and we're trying to divide this over the 10 years in order to find what would be equivalent. So adding all these numbers together, that would give you a $25,475, the annual worth for alternative B. And the final decision that we will the final decision should be selecting alternative B, because this will be the less expensive option. Thank you. I hope this is helpful.